Hello and good morning to everyone. This is Mr. Hill once again with some more science. We're going to talk about today dealing with solutions. We have talked about bonding, different types of bonding, also compounds in itself. And we're still continuing with our pure substances, mixtures, and compounds. And solutions is a part of all these topics here. Well, a solution is simply a homogeneous mixture of a pure substance, is what is how we call it. So we talked about before about homogeneous solutions where everything mixed together and looks like it's the same. So chocolate syrup, strawberry syrup, rubbing alcohol, hydrogen peroxide, coffee, tea. We talked about those things before. Also, the solvent is the medium in which the solutes are dissolved. In other words, when you for example, when you make a cup of coffee and you add sugar, even when you add sugar to it, it still is a homogeneous solution or a mixture, if you will. So the sugar dissolves. So in that example, the sugar will be the solute. It'll be the thing that's dissolved into the solvent, which would be the black coffee. Now, if you mix cream in there, then that's a different situation in itself, depending on what type of cream you use. But if you just take black coffee and add sugar to it, the sugar dissolves into the coffee and it's still a homogeneous mixture. And therefore, the solute will be the thing that dissolves into it, and the solvent will be the coffee itself. So here are some examples of that. Salt water. Salt is a solute, and water is a solvent, as we can see. Now, how do substances dissolve? We talked about this the first trimester briefly, but I do want to reiterate it, and we're going to most likely cover a little bit more in detail on the next few days, which is kinetic theory. In kinetic theory, according to the textbook Hope on page 92, it talks about how, according to kinetic theory, the water molecules in each glass of tea are always moving. And some water molecules collide with sugar crystals. When that happens, energy is transferred to the sugar molecules at the surface of the crystals. Now, here's a more clearer way of explaining this. Kinetic theory is simply that all particles have movement, and this movement is constant. That's basically a summation of kinetic theory for right now. Just to give you a very short-winded one, is that all particles have movement, and this movement is constant. And we know that all particles have movement just from understanding the periodic table, with the electrons in itself periodically appearing in one place or another within a certain electron or certain electron state, if you will. So think about it that way. All particles have movement and their movements are constant. All right, moving on. And the whole collision thing about those particles colliding, they're going to collide when you actually go back to the slide with kinetic theory. And collision is where things begin to interact and collide. So anytime something's moved, it takes energy. And when you have a collision, that's going to involve energy being transferred. And we could talk about that a little bit later going on, but just keep those things in mind. All right. So what's called dissolution is very similar to disassociation, which means that things will actually break down or dissolve in a solution, may it be of water or some other substance. And so a decrease in energy of the system, exothermic. Exothermic means that energy is released. And so when an energy is released, that means energy is leaving the system. So one example of energy releasing, leaving a system would be a cup of tea, a hot cup of tea. When the tea is hot, it is going to have a certain amount of heat to it. Heat is known as a form of energy, and that energy will start to transfer eventually inside that cup of tea. And why? Because the heat will begin to go out into the atmosphere around the cup of tea. The cup of tea is a system, and the heat leaving the cup of tea is the same as the heat leaving a system. So there's a decrease in energy. And what happens is that the tea becomes cold or it begins to decrease in temperature. Also, an increase And disorder of the system means entropy. That means when things start to function the way it was not formulated, designed, or put together. Entropy is something in which is known as a disorder. It's talked about a lot in the subject matter called thermodynamics, but we will cover some of these topics moving forward. Liquids dissolve in liquids. So, for example, a liquid that is soluble in one another are miscible. Likes dissolves likes. So polar liquids generally dissolve or basically is soluble in other polar liquids. Non-polar liquids are generally soluble in other non-polar liquids. So here's an example of that. Soap. Liquid soap dissolves in water. If it didn't, then you could not wash your dishes. If you use Dove, if you use palm olive, liquid soap to wash dishes, the soap has to be soluble in water for it to be able to dissolve in the water and get what's called soapy water. Even soap powder, if you use the powdered soap for your dishes, if you will. And same with anything else that is in that same type. So one example of things not mixing together would be water and oil. Water and oil don't mix very well. They don't blend together very well. You can mix them together very hard with mechanical processes, but over time they start to separate and they're not dissolving the soluble. I mean, most things, if you dissolve them over time, begin to separate, but they really don't mix together at all. Water and oil, that is, to be exact. All right. Now, here's some factors that affect the rate of dissolution. And dissolution is dealing with things being able to dissolve or to actually mix together. Surface area, particle size. Greater the surface area, the faster it dissolves. So, for example, if I have a thin layer of, well, Alka Seltzer is a good example. Alka Seltzer tablets are very relatively thin and they're circular disc. They're not the thickest, but the size of the disc is round enough to where it can dissolve in the water within a reasonable amount of time. Also, the temperature. In other words, and another thing, another example of surface area, real quick, is that of what's called bouillon cubes. Some pronounce it bouillon or bouillon, and these are cubes used to make the broth for chicken soup, vegetable soup, or even beef stew. They look like chewable candies, but they're not. They're usually wrapped in some kind of foil, and they have a shape like a Jolly Rancher. You can throw it into the water, and unfortunately, those cubes do not dissolve very fast. It's always good. I've learned from my own experiences to break them up a little bit once you get them into a hot pot of water because they're usually made up of substances of spices, oil, and some other things to flavor the water to make it ready for a soup or a stew. But their surface area is shaped like a Jolly Rancher, a three-dimensional rectangle, if you will, but a circular disc with a small thickness has a large surface area for the water to interact on. So Alka-Seltzer tablets usually dissolve pretty well, and most tablet type of dissolving things out there nowadays because you can get just about any type of anti-acid for upset stomach as a tablet. Most of them have a very circular, round type of design to them for that very reason. Temperature, of course, the more the temperature increases, the most solids will start to dissolve faster. If you put in salt in the boiling pot of water versus a pot of cold water, the salt is going to dissolve much faster. Agitation. So that's shaking or striking the surface, if you will. So another way of thinking of this is a washing machine, because washing machine has it where it rotates. Some of your older models by Maytag has the uh, arm in the middle, or you see like that peg in the middle that begins to become a part of the entire that's woven into a pattern that fits basically in the middle, in the center, and then it flushes out with the rest of the container of the dishwasher on the inside. I mean, not dishwasher, excuse me, the wash machine on the inside. And because of that, that arm rotates in a particular motion that kind of goes back and forth a little bit. So it rotates and it pauses, rotates and it pauses. And that's to cause agitation. That is to strike or shake up the dirt and soil in the clothing to get them clean. Another way of thinking of it is like if you are dissolving bouillon cubes in hot water, you can use uh, a pot spoon to break up the bouillon cube so it dissolves faster as well in there. And so striking and beating the surface of something for it to react will help break something up as well. Saturation. There are different types of saturations. We're going to talk about three main ones. One is the unsaturated solution. It's able to dissolve more soluble, means that it can take on more things in it and still appear to be homogeneous. A saturated one has a maximum amount of solute in it. So the amount of liquid that can dissolve, the amount of solute are actually equal to one another. So it can take on nothing else. A supersaturated solution a has a dissolved high amount into the solution. So at that point, you'll start to see crystals start to form. So if you took a cup of water, which is 8 ounces, and you try to dissolve 10 ounces of sugar in hot water, you may start to see at a certain point, depending on the type of sugar that you get, uh, table sugar, for example, crystals start to form in the bottom. And I can almost guarantee you, if you take 16 ounces of sugar, table sugar, and try to dissolve it into 8 ounces of water, you would definitely start to see crystals start to form at the bottom, and you'll see these white crystalline structures, and that's because it is oversaturated. Another supersaturated situation we see a lot of times is dealing with the concentrates. If you buy for Hawaiian Punch, for example, you can go to GFS or Gordon Foods, you can buy drink concentrates. And what that is that this is the concentrate that you use to pour into a container of water to make multiple amounts of Hawaiian Punch, for example. When I was younger, you used to be able to get that a lot from the grocery store. You'll have uh, soft drinks that are done like this, where you have, like Hawaiian Punch was a popular one. You'll have the fruit juice concentrate in the freezer section, or the Hawaiian Punch, or even the high C concentrate. It is a super sugary and highly flavored substance that you dissolve in water to make the soft drink itself. It would definitely make you probably sick if you was to drink the concentrate like it is. It's super sugary and it's not good for you. Also, if you go in the freezer sections, and still to this day, like at Kroger's, any grocery store, they sell the fruit juice concentrates. It comes in a round cylinder container, and it might say orange juice concentrate, grape juice concentrate, apple juice concentrate. And if you follow the instructions correctly, it'll tell you how much water you add to it to make a large container of that type of drink. All right, solubility is dealing with the amount of solute that will dissolve in a given solvent. So in other words, the amount of a substance that can dissolve in a solution. That is a solvent. It might be made out of water or a water-based solution. It could be even oil. How well that thing dissolves inside that solvent, the solute that is the solubility. Some things have a high solubility, some things don't. The factors that affect it is one, the nature of the solute and the solvent. Different substances have different solubility rates. Some things dissolve very well, some things don't. Things that dissolve well in water may not dissolve very well in oil. It's going to have a different rate. And the reversal is true. Some things dissolve well in oil may not dissolve very well in water. And also the temperature. Some things become more soluble as you increase temperature. Now, however, in the case of gases, the less soluble in the liquids at higher temperatures because gases begin as you go higher in temperature, become more excited and begin to fly around. Gases typically become a liquid form under pressure, if you will, and it begin to become cold. And we'll talk about things that lead to why that's the case, as far as gases coming cold under pressure. We'll touch on it in further lessons on this topic. Also, pressure only affects the solubility of gases. As pressure increases, solubility of a gas increases. Yeah, because the gas in itself starts to make the pressure start makes the gas become closer to what we'll call a solid or even a liquid. Now, here's the virtual assignment. You have assignment called solution type. Please do the solution type assignment. You can contact me through Schoology or at the email address below. And with that being said, thank you for watching and have a great